Hey guys, welcome to our next brown bag. Oh, that's a good spot right there. We have today with us Alex Morot and Brendan Jennings. Who are going to talk to us about continuous integration. They're both engineers on the Quickbooks support team over at Intuit, and they've been living this for quite a while, so excited to hear what they have to say. And please welcome them.
Hi everyone, thank you for coming. As Aaron said, I'm Brendan Jennings. It was never intentional to put two British accents in for the two first brown bags, but don't want to give everyone the impression you have to be British to speak at one of these, so I've asked Alex to join me as well.
So I'm Alexander Morot, and after two British accents, it was only natural that it would be a French accent.
So now you know, you have to be European to speak it. Yes, we both work at Intuit, and just to get the legal stuff out of the way, these opinions are ours, nothing to do with Intuit. Just a quick overview of the presentation then. Let's briefly introduce what continuous integration means before going into it a little bit more. Can everyone hear me okay, by the way?
I'm sorry.
Okay. Good. Then we're going to look back at where we were a couple of years ago and where we were struggling. Then I'm going to talk about the role of the build server. Then we're going to introduce unit tests and how that all fits in. And then I've asked Alex to do the presentation on automated deployment because he's built all of the functionality for that, so he's much better at talking about it. Draw our conclusions, has it helped? And then we're open for questions. Okay, so continuous integration. A lot of projects, especially traditional projects, if you've got multiple people working on the team, then they're all working on their bit of code, and at some point all that code's got to come back together. And some projects left the integration phase quite late in the game. I actually worked on one project where after about 18 months of development, with everyone working on their code and stub methods for everything else they called, they tried to integrate it, and that's when I left. That was a disaster. So continuous integration is simply not putting it off, doing it all the time, and it's however you want to interpret that. And this is going to be about our particular journey, but there's lots of ways of tackling this. So to understand why we did it, we're going to have to look back and talk about where we used to be and where we were suffering. And the first problem that we got a lot of was broken builds in source control. It's a combination of these two. So these are the issues where you try and pull the latest copy of the source onto your machine, and you get the "it works on my machine" syndrome, but they're the only person that can say it. There's quite a few reasons that we saw. I mean, there's lots of reasons this can happen, but there were some real common issues that we went through. DLL references were a particular pain point for us. Any time that the source is dependent on a compiled binary, one reason could be that the person who checked in the code has built a reference to a specific path, and that DLL is in a different location on someone else's machine. Maybe it's program files instead of program files x86 or whatever the difference is. Maybe it's a different drive. Or it could be they don't even have the DLL on their machine. It could be that they've built a dependency on a plugin, and that plugin has never been made aware to anybody. There's another thing that we tended to do where the reference is actually to the DLL in the output directory of another project. And this is a real mess, because if you come in from scratch, you try to pull the solution, you can't build it, then you find you've got to build this other thing first, and you can't build that because you've got to build that first, and you end up having to build all these things in an unknown order that you work out as you go. But it's even more complicated than that, because even once you've got it building, if somebody makes a change to one of those underlying projects, then you don't necessarily know that you've got to go through this intricate build order to get the code all back to where it should be. So this was a really bad technique and caused a lot of issues for us. incomplete check-ins where someone has checked in some of their code, but they haven't checked it all in. So again, it works on their machine, but nobody else's. In C#, the way, that's what we use obviously, you have a project file, and the project file lists all the source files that are going to be used. One of the things that, again, we've seen quite a lot of is someone checks some files in, and when you add these new files to the project, the Visual Studio IDE automatically edits the project file for you. But if you forget to check in the project file, then as far as anyone else is concerned, these new files don't exist. When it does the get latest, it pulls down the project file, and then it looks in there to see what else it has to pull from source control. So how this might get you, someone might add a class, then they make some changes to some other files to start referencing this class, check it in, you haven't got the project, you can't build, you don't even know what this class is. Slightly less frequent, but doing it the other way around. You put the project file in without the files that it contains. One reason this may happen is if you have two sets of changes that you're working on simultaneously to the same project, and you've added files to both sets, and then you're ready to check in the one set, and you deliberately deselect all the bits that you don't want because they're not ready yet, and you end up finding that the project file has actually added references in to those files that you deselected, and again, nobody can build. Another problem that we encountered resulted in overwritten changes. Again, there's a couple of reasons that we saw that happen. We use optimistic checkouts, which basically means multiple people can check out the same file at the same time. When you check in the files, you have to resolve any changes that have been made by other people. And usually that is quite an easy process. The changes are matched up and everything's really easy. But if those changes conflict with each other and you rush the merge, you could miss something, you could lose someone's changes. Another reason I've seen this happen is where someone's put some changes into source control, realized that was a mistake and backed out those changes, inadvertently backing out someone else's changes at the same time. There's also when you do the check-in. There's a comfort of having things checked into source control and then you know that it's there. But it has encouraged a practice where somebody might be bet to go home at the end of the day, or maybe they're bet to go on vacation, and they rush to get everything ready and check it in, and it's not really ready. And then again, that can cause broken builds. So with all these other issues that I've talked about, there's a feeling that you might not want to get the latest build. You might want to stay in the comfort of the build that you know works on your machine. So you don't touch that and you just make your change in isolation. But this is actually even worse because then you've still got the same problems that you had before, but you don't know about it. And then you could be writing code that's using library code that's since been refactored and you don't even know about it. And it's just making the issue worse. And also when you finally do find out that the build doesn't make sense, it could be a much bigger task to actually put it back together and get it working. So our experience at this point was, I would guess about maybe 1 or 2 days a month, the team was trying to work out how to get the solution building again. It was a real waste of time. Another pain point we had was related to manual testing. Now, this isn't to say that we shouldn't be doing manual testing, because obviously we should. And this is very specifically the more technical testing that developers would do, as opposed to maybe the more end-user testing that the QA department might take on. But it's very time-intensive. It's something that, realistically, most developers would rather not be doing or minimizing. They don't want, they'd rather be writing code. And another thing that is true is there's no real full regression test. If you've written something 2 years ago, you may have tested that to death. But 2 years on, and you need to retest everything and make sure everything is still functioning. Are you really going to put a lot of effort into this method that you haven't touched since and hasn't broken since? Probably not. Another thing that most people don't like to admit, but we all know is true. If you're working towards a deadline, then everything beyond the code is the stuff that gets compressed. And if you're overrunning on your code, then there's a good chance that that's because some extra complexity or some extra pressure has come along, which means that the code probably needs more testing than it did before, but that testing time is going to shrink. So once you've got everything building correctly and everything's tested, you've got to get it out onto production. Our applications are all web-based, so we've got to get it out on the production server. The first pain point we had here is that there's a fear of people working on a production system. Anything that goes wrong is going to be straight in the customer's eyes, and that's not acceptable. So we had the concept of an observer, which is a second developer who just sits there and looks over the shoulder of the person who's doing this production push, just to make sure that they don't mess up, just in case they miss a step or they do something wrong. And to get it to production, there's quite a few steps involved. The first thing we've got to do is actually get the package built, get everything compiled, get everything together in such a way that it is ready to go onto a production box. We then need to zip up that package and push it into the data center. Then we can remote into the data center and pull it down onto our pre-production box, extract out the contents of the zip and replace the build that's on the server, and then start the manual QA. So this is the production QA. This is make sure everything that we think is in the build is still in the build, is still working. Anything specific to that environment, for example, database connections may have been changed out since it was QA'd before, things like that. Make sure all of that is working. And if that finds any issues, then we're around that loop again. We've got to go back, fix it, and go through that whole process again. Sometimes we can take a bit of a shortcut if it's just a CSS file or something like that that we need to fix, but quite often that's not the case. Once we get past that, for every one of our production servers, we have to remove each server from rotation, essentially taking it out from behind the load balancer so that nobody's able to access that server from the outside world. We again have to extract the same build we used in pre-production over the top. Then we warm up the server, which is where we hit the pages on the server, a few key pages to get the site back into memory and get it responding, because those first few hits are quite slow and we don't want customers to have to go through that. Then we can put it back into rotation and it's live to the world. Then we pray, and then we're done. And our typical time would be about 2 hours for our experience. Sometimes it would go quicker if there were no issues, but yeah, about 2 hours of 2 people's time to actually get something out on production. But this leaves a bit of an issue. At the point we start pushing these production servers, you now have servers that have the new code on and servers that have the old code on. And people are flipping back and forth between them because the requests are not sticky on our load balancer. So you could see the new site and then the next page you could see the old site. Or even different requests for the same page. And most of the time that's not actually that big a problem. It can cause a couple of unpleasantries, I guess, for a short window. But sometimes it's actually quite serious. Now when it's serious, we have no choice but to take the site out of production, put in a turnaway page for the entire time we're doing that push. And that's something that we really don't want to do. So that's where we were. I would say that's about 2 years ago I started, just over 2 years ago I started the company, and that's the sort of situation we're in. And we wanted to get out of that mess. So the first piece is to put in the build server. And the idea really is all of those build errors that I was talking about before, it's not going to solve them, but it's going to validate that they're not happening. So every time somebody checks into source control, it's going to do a build immediately. That is configurable. Some people might not be in a situation where they could do that, particularly if your build time is especially long, but you might want to build overnight or 2 or 3 times a day, but we've triggered it on every single check-in. The software we've used to do this is well, it was originally Hudson. Since then Hudson forked into Hudson and Jenkins, and we decided to take the fork. We switched to Jenkins. So it runs that build. If there's a problem, an immediate notification goes out. And it goes out to everybody in the team, including the manager. One of the things that notification does is it names the person who broke the build. It's going to be, Alex has checked in this change, and it's broken the build, it's now producing this error. It's all there in the email, everybody's got it.
You hard-coded Alex's name in there?
We did, yeah. It's all hard-coded.
I just have to stop and say at Gangplank Success, they have this giant, nasty-looking sombrero, and they have like a big board. If you break the build, your name goes up. And you wear the sombrero.
That's cool.
Yeah. So we may institute that here, or a different hat, maybe. So.
We thought about, I bought the build t-shirt.
We got some, but they sent them to us all in smalls, and as you can see, none of us fit. We got
Say
Brendan
that
where
guy
it was a half shirt.
Those emails also come through to our phones. Everybody on the team has smartphones, and so we know that if they've done the check-in and run at the end of the day, they're still going to get that notification to let everyone know what's happening.
Could you just elaborate on what the Hudson Jenkins?
Sure. So Hudson is a open source project. I think it was originally developed by Sun, and it's basically an automation server, and you basically set up jobs. It's very flexible, but the way that we've used it, it monitors the source control environment, and it looks for check-ins, and then you can trigger a build, and if the build fails, then it spits out an email.
Are you guys using Visual Studio and SourceSafe?
We use Visual Studio and Tfs, which is the new version of SourceSafe. This is an independent package. It's not, even though we're very Microsofty, Hudson is really not. You use plugins to configure it for whatever you want to use.
But it's willing to talk to the Microsoft.
Yeah, you can get plugins for pretty much any programming language that people are likely to use.
And Alex will probably talk a little about this. He built an open source plugin that actually, or he augmented the open source plugins that it worked for.
Oh, nice.
So this really encourages pride in build quality. Nobody on the team wants the entire team to receive an email with their name on it and a broken build message. And this really works. I will say that in the early days of us putting this in, there was a level of, I think it's wrong. The same sort of issues we'd had when we gone to someone and say, you broke the build, and they're like, no, it works on my machine. But after you've been shamed 3 or 4 times and you've been proven that it was your fault every time, then build quality starts coming up. So that means you only want to check in working code. You really want to be careful that you don't make these mistakes. You don't check things in at the end of the day without really testing them, because you know you're taking that risk. The attitude on our team is if one of these notifications goes out, it's got to be addressed immediately. You can't leave a broken build hanging around, because you're impacting everybody on the team. Especially now we've adopted a setting in Visual Studio where every time you open Visual Studio and you open a project, it automatically updates some source control to make sure that nobody is lingering on old code. If someone checks in some work, it obviously runs another validation of the build. And if it hasn't fixed it, it sends another notification. It's like, why are you working on this when the build's broken? So it's going to keep lagging until that build is fixed. And then,
You're checking it in, but are you deploying this code when you do that, or is that another step?
that's another step, and that's actually the piece Alex will talk about. But yeah, so this is just the validation at this stage.
So now really only the team knows it's broken at this stage.
At this stage, it's the team is aware it's broken, and they're impacting other developers.
Do you guys feel like you're spending a significant amount of time now on building?
I would say no. These builds, the Hudson is actually very easy to configure. And for the effort that it takes and the amount of time it saved us, like I said, we've got to go back to like 1 or 2 days a month of trying to work out why you can't build anymore.
Oh, we were losing a lot more time than that, so.
And then you get the issues where you go to somebody and they say, okay, I'm going to fix it on, and they fix it on their machine, but now they've broken on everyone else's, and it's just moving around the room who's got the working build. So yeah, it's definitely saved us a huge amount of time. So this validates the build. You know you've got a good compile. What you've got is going to compile, but there's also, does it work? So the next piece of the puzzle is unit testing. So these are all the coded unit tests that we should have been doing all along, but really this has motivated us to really focus on this. So considering we have a lack of unit tests, the first task is to start getting unit tests in for all of our existing code, so we can actually verify that it's working. So we've had a focus on the most critical areas, the areas that are being hit a lot, or the areas that are most likely to break. And this is an ongoing exercise of just going back through all of our code and making sure that it's got the unit test coverage that it needs. It's also a change of attitude, so that you can no longer think about just writing the code. You've also got to think about writing the unit test to go with it, so that all of our new code or any updates to the code is also covered. And then you can put the test execution steps onto the build server. So this is a bit more configuration on Hudson or Jenkins that tells it to run the unit test package. Once you've got that, you get the same kind of notifications for breaking a test as you get for breaking the build. Also conveniently maintains a history, so if you've got tests that are broken over several builds, you can actually go in and there's a lot of interesting displays to see how long something's been broken for. You can go into the history of any given test, how many tests are broken on different builds, so you can see that things are getting better or worse. However, our attitude is that all tests must pass. So that history shouldn't actually be that valuable to us, because we just want to make sure that everything is 100%. So we have a couple of philosophies here. If a test has uncovered a bug, we have to fix that bug. But likewise, if a test has failed incorrectly, we have to fix that test. So I'm going to pass over to Alex to talk about the next piece, which is deploying it onto the service.
So the third portion of the continuous integration is the deployment. So as Brandon explained earlier, the deployment was a very painful process, very lengthy process, and involved a lot of manual tests, so very prone to error as well. So we've done two things. There are two strategies for the deployment. The first one is that basically we installed a server, dedicated server that will host all the latest build. So in Jenkins, we created a job basically that will check every 5 minutes against source control to see if anything new has been introduced and checked in, and it will deploy it directly into that box. For the successful build, of course. The advantage of this is that you can always see what is the latest development, and it can be very useful for like a multi-browser testing, or if you want to give a preview to a customer, or even if a QA wants to get a foretaste of what they're going to have to test against. The second type of deployment that we have is the deployment to the data center. Unlike the deployment for the latest build, we have to be able to pick and choose which version of the files we want to send to the data center. So to be able to choose which version of the files, which packages we want, we use source control labels in Team Foundation server. So what is a label? A label is basically a list of files at a particular version. So, as I say, it allows us to have a precise control of what is in each build. But the good thing is that we now have a history of all the prior builds and pushes that we've done. So, for example, if we do a push, a deployment onto production, and we realize that something is going wrong, we can very quickly revert back to a previous state at any given date. In this screenshot, this is a screenshot of Jenkins, which shows you the history of different pushes. So we know what was in each package at each time. We can know which build we can go revert to if we need to. For the deployment to the data center, everything is automated. There is very minimal manual interaction. You just push a button basically. So we're going to talk about that. Here's another screenshot of Jenkins that shows the 3 different environments that we have set up. So the way it works is that once we know we have created a label with all the files that we want in the package, then we push the button for the 3rd line and we push it to a staging environment. Staging environment is basically a QA box, basically, where the QA is going to be performed. Once QA passes, we have all the green lights. Then at this point, we are going to push it to the pre-production. What we call the pre-production in our case is that we just take one of the servers, of the production servers out of rotation, and we push the code into it. So here are the steps that the script will do. You will take that one server out of rotation, and then it will do a differential push. Differential push meaning it's going to compare what's on that machine and what's on the push package, and only push the files that it needs, because the push package contains all the files, the whole build, so that will accelerate the actual transfer of files. Instead of transferring 2 gigs, you just have to transfer, I don't know, 500 kilobytes or something like that. Also, what the script does, it will check for deployment errors. So once the deployment is done, it's going to go through the logs of the deployment to see if any anomaly occurred. Usually when there's an anomaly, it's either a connectivity problem, or it could be an authentication problem, or also what I've seen is that if the target destination of the website in IIS on the web server doesn't match the one from the package, then it will throw an error as well. Once the package has been verified, well, it's time to do a manual verification. This is the last step, the last manual one, last QA basically. At this point, the pre-production box is approved.
What is that basically? Just like clicking around the app, making sure it works? Or?
Yeah, basically we go on the website, we go on the application, and we make sure that every key component of the site is working.
As a user?
As a user, yes. Make sure it works fine against the hardware as well. At this point, so the pre-production script is done, and we go back to our dashboard and we click push to production. And here is basically, this is the log file that you see when you actually do the push. And we're going to go through the process. The good thing about this script is that it does a mass push. So what we do first, we take out of rotation half of the servers. This process takes like about 5 seconds. It's very quick. Once it's pushed, once it's taken out of rotation, we usually have a timer that waits for 2 minutes to make sure that every user that was on those machines has been redirected to the other machines on the load balancer, just a precaution. And then we start to do a parallel deployment with differential pushes. Once this step is done, it's going to start instantly to warm up each machine. At the same time, in the background, as the warm-up is being done, the logs for the deployment are being verified, that nothing wrong happened on one particular server. And then after the warm-up is done, it's going to display if server passed or failed, basically. If any of the server has a failed, it's going to abort right away to push the deployment. So meaning that we still have this other half with the old build. And so that we have time to go back, see what's going on, fix the problem, re-push to production, to pre-prod, and try to push again. But the only problems I had before were just connectivity. One of the server was not responding, just needed to restart it, then rerun the script again. Something to note also that I didn't talk about before, the package is built during the pre-production process, and when we push to production, we reuse that same package it was for pre-production, so it doesn't have to rebuild the second time. The neat part here is we don't have a half hybrid site anymore with the old and new stuff at the same time. Everything is swapped. This process takes about 2 to 5 seconds. Well, the newly pushed servers are checked in, while the other ones are checked out. So we just flip a switch. We don't need to have a turn away page, take down the site or anything. And then we repeat the process. We start differential push, parallel push. Then it warms up again. Once the warm-up is done, verification. Once everything is passed, then the remaining servers are checked in. At this point, there is a last check that verifies that all machines are behind the load balancer again. And if you see at the bottom, it says push performed about 6 minutes. So we're going from 2 hours for about 6 minutes. And there is no manual interaction besides just clicking push. Now, we're going to talk about the technologies that we've used to be able to do automated deployment. So the first tool I use is Microsoft Web Deploy. It's version 2.1 actually. And Microsoft Web Deploy is a command line tool. What I like about it is that it integrates with IIS, but also it integrates with Visual Studio. So it's actually possible to do a deployment directly from your Visual Studio if you have the right AC as in connection to your servers. But what I like about it is that Web Deploy can be scripted, and that's why I chose it. Now, we use also Cygwin bash scripting, and the capability of Cygwin to be an SSH server. We are Windows-based, but I wanted to be able to exploit SSH capability. We use the SSH side of it to perform check-in, check-out, and also to verify the logs. And the bash script is used to control the whole flow. The bash script will dynamically build the MS deploy scripts according to the type of machines and the sequence and the parallel push and all of that.
So you wanted that for the scripting, like the bash scripting?
Bash scripting.
Yeah.
It's basically a hybrid of Linux and Windows command.
Right, yeah. Oh, nice.
Use the best of both. And of course we're using Jenkins. Brendan explained what Jenkins was. But I wanted to emphasize that we use 2 particular plugins in Jenkins, 2 open source plugins. So the plugin for TFS that allows to pull source control, to be able to build this, pull information for source control, and MS Build to be able to build. Now something to note is that we have customized the TFS plugin, because the one you find out there, the open source version, only allows you to pull whatever is latest on your source. But we wanted to be able to target which label we wanted to. So we downloaded the source and updated it so that it could handle label strategy. So on this slide you will see that where it says like label version, this is a new field we have added, as well as a label log path. Because we needed to be able to track history with labeling, which is not handled by the TFS plugin. So we created our own history version. Now on the second red box, you see this is the MS Build plugin. This is what will actually build the zip package that will be sent via MS Deploy. And finally, something to note is that the deployment script that was written in bash is controlled by Jenkins. Basically, it will wait for the package to be built, zipped up, and then it will trigger the actual deployment script. Give the ball back to Brandon.
Thanks, Alex. So now we've taken you on our journey, let's see where we arrived. So the first thing we want to look at is the quality. Has this helped with some of the quality issues that we were suffering with before? With definitely has. If there's an issue with the build, it's identified very rapidly. We're typically looking at within 5 minutes it's going to notice the check-in, pull it out, and notice the failed build and notify us. So we got rid of those Monday morning blues where someone was working late on a Friday night, got tired, went home, checked everything in, and everyone comes in on a Monday morning and they have no idea why they can't build. We've also done a lot of work on adding all of our automated regression tests, and that's given us a whole boost in our confidence level that what we're pushing out is actually going to work. We know that some of the things that we found through those test failures are things that we would not have discovered. They would have gone out onto production and we wouldn't have found out about it until somebody told us that we'd broken something. And in particular, I have to say that analytics bugs are an area that you don't notice problems with analytics if you're testing directly. The link between what you're doing and what's going on in your analytics database is too vague. You've got to actually sit there and look at the source in the HTML to see that there's a problem, and we just didn't spot stuff. These tests will pick it up. In terms of the automated deployment, I think this speaks for itself actually. The fact we only need one person to run a deployment, we no longer have that observer who's using their timer. We don't have that confidence fear anymore that we need that extra person involved. Because of the way that half and half switch over of the servers operates, then in those cases where we're pushing a build that would be broken, if there was a half and half situation, that's been eliminated by this. So it's very, very rare that we push anything that would need any downtime now. Deployment time is reduced to 6 minutes from 2 hours. Obviously that means that we're a lot more productive, but it also means that we used to batch up changes. You know, we didn't take every little task we did and then say, okay, let's get it to production. We used to plan that, okay, we're going to do a release on this date and we're going to get everything together. We don't need to do that anymore. We got something, it's ready, we deploy it. We also do multiple deployments in the same day. Something could be ready in the morning, something could be ready 2 hours later, do another push. From the 2-hour window as well, when that's how long we anticipated the build would take, you've actually got to find a 2-hour window. We tend to have quite a few meetings, so that can actually be quite difficult to find. That fear is completely gone. If something does break, we've got the exact same convenience of rolling back now. We just pick the label we want to roll back to and deploy it. 6 minutes later, it's out there on production, we're fixed. Actually less than 6 minutes, because it's obviously deployed at the point that half of the servers are back in again. So. And the deployment can be unattended. Just because it takes 6 minutes, that's not 6 minutes of our time even. We just have to push build. We don't have to actually sit there and monitor it or watch it at all. We know that if anything goes wrong during that process, it's going to send out a notification and it's going to abort the build. So there's no risk. At the point that it aborts, either it successfully pushed half the site, but we know that half worked, or it hasn't got that far, and so there's no harm done. We also don't need to log in directly to those servers anymore. Everything is controlled through this automation script. The real advantage to that is that sometimes when things aren't quite working, and you want to get a quick fix out, there is that temptation just to get on there and make a quick fix directly on the server. And then, of course, you have to replicate that fix on every server, and there's always that risk that one of those fixes wasn't quite right, or that the replication of the fix didn't get made back into source control, and then the next time someone does a push, the problem's back again. So that's really eliminated. So I have to say, I think this has been really successful. And that's it. Any questions?
I have a question.
Sure.
Why are you still doing the manual step and not letting, not letting Jenkins monitor for a specific label and just deploying automatically whenever that label is?
That's it is a feature that we have added to the TFS plugin. It is true that we can now monitor a particular label, and if we see any changes to that label, we can trigger a push automatically. I don't know what we haven't done it yet,
There are QA issues there. I mean, we still want to, we're not quite ready to take that leap of if it's checked in, it's ready to go to production. That's a little bit more scary. So yes, it will go to our own development server, but we still need people to sort of to sign up on it and say this is good, and then we can gather it up and label it and push it.
Or put another way, has the build ever been successful, got to deployment, and then failed to the extent that it had to go back to the build?
What's happening is that the creation of the label is manual in TFS. You say, create a new label, say you want to apply the latest changes, or you choose which version you want. At that point, if the label hasn't been created, it's not going to do anything. Plus, the way we work in the TFS plugin, we have a label that never changes. So we create a new label, and we copy that label to that label that's not supposed to change in the plugin. So that when the plugin says that there is a difference, a change in that particular label, it can trigger push. So it's still a manual process anyway in TFS that we have to do. To say, okay, now we want to push, we change the label, now it sees that the label has changed, push is triggered.
So I was asking kind of a leading question, but the decision we made was at this point, until we had like 100% confidence with how much of our test, how much test coverage we had and stuff like that in the regression test, so we were going to leave it manual, but also there was more comfort in having that manual process of saying this is what's been signed off on by our particular customers within the organization with this stuff. But this is completely built out to be completely automated. If you didn't want to have that security measure in there, this would push all the way to production without any interaction with full tests and so forth.
And that's how we have to implement our history logging, because Jenkins was not handling that. It keeps a log and then a file with a snapshot of basically what was inside the previous label, because it's the same thing. And then when you compares it, the new one with the old one, you see the difference. Then pushes.
How much time did you guys invest in writing all the scripting and the plugins and that kind of stuff?
That's definitely an
Well, I
hour's
started in April, finished in September, but I was not working every day on it. Plus, I was working it when my other work was all done, so I would probably work an hour a day. So, what took me a long time was not actually writing the script, was the learning curve, because there was not a lot of documentation on MS Deploy at all. And also we were moving to data center, so there was a new strategy. We had to set up the ACLs, and we had to get to know the new data center as well. So these scripts, we started to use it when we moved to our new data center.
And there were a lot of exceptions were made too, because typically Intuit's not hosting a lot of Windows technology, and so we had to make all of it work. We had to get a bunch of exceptions for security and so forth that they don't normally make, certain ports that need to be open like for MS Deploy and so forth, and then we had to get an exception for wanting to run SSH servers on Windows machines and so forth. So there's a lot of things that I had to escalate as the manager. I had to escalate and get things done, but ultimately it was worth it because now we have this product we can demonstrate that makes Windows technology much more accessible and so forth.
Yeah. I'm thinking about rewriting the script in PowerShell as well. And also we make the TFS plugin for handling labeling available.
Contributed back.
Yeah, we contribute back, but we just need to do a few code reviews and refactor the code, and it will be back.
Was there a solution? You could have just said, oh, let's just buy everything off the shelf, but I know you have your certain business strategies and goals of how you want to handle deployment, builds, and so forth, but could you, if you had chosen to, just say, let's buy all these products and with minimum configuration they'll work, or is there nothing like that truly exists out there?
There are some technologies, but you end up in a situation where do they plug into your organization?
Right.
How much work do you have to go through to make it work?
Right. Should you just do this in the
network
beginning?
topography and certain policies and so forth, and data center policies. So this was, how do we take all of these different components that are out there that will fit together if given the right adapters or the right bridge, how do they fit together and do that within our technology?
So it's really kind of driven by, okay, there's certain portions of the way we develop to stick with this. So let's build the deployment and then the system around those things that we know are like fixed development entities, so to speak, right? This is, we develop in C#, that's a fixed development, strategy. We're not going to change that. So now that we know this and a few other things, let's build this whole system around it. It's kind of like that.
I think so, but I think it's also at both sides of the fence, because even though we had to push the data center hard because they've got such strict policies about how things are done.
And wait, so are you telling me that Intuit doesn't like have its own data center?
Oh no, it is Intuit's data center.
Oh, it is. Okay.
Yeah, but they have very strict policies about how these things are done.
So when you talk about it as though they're like,
The security is very, very tight.
right, for obvious reasons.
Yes, because we handle people's financial information.
Yeah, so there's a lot. So we had to push them hard. As Seth said, there's a lot of escalations involved, but there's still limits that they were never going to give on. So it was getting things to fit at that side as well. Like, where can we push them, and where is there just no give?
So then you
just
can
both
work around
ends.
those limitations.
Yes. We had to put our deployment box in an area that could access all the
So that's
servers.
security itself.
Yeah. So we're actually moving it now to the data center,
Uh-huh.
and we're just exposing the web interface for us to be able to go and trigger push.
Right, okay.
So do you guys have any issues with persistent data? I mean, do you have a database and schema and other stuff behind that? How do you deal with that with regards to this?
Well, for MS Deploy is capable of handling deployment databases, but we haven't gone that far. Right now, when we do database deployments, it's still a manual process, but we are going to include it eventually.
You're talking about like for data migration and
Yeah, because I'm assuming that for your minor changes, there's no change to your schema or your database.
Right.
And that sort of stuff.
So
But if you guys have a schema change, you have to do a big version change.
So I think you picked up on the fact I said in most pushes now we don't need to put the turn away page in. That is one of the exceptions, but it's fortunate that because of the nature of our site, we don't actually make that many database changes. Most pushes are just code.
Right. And because it's in C# and you're doing MS build, you guys can't just do a really common thing I see on the Unix side of things is if you have a scripting language, you just have the live server have a checkout of your version control, because there's I'm assuming there's some compilation phase that through MS build, and that's the reason why you're doing it through that other way.
Yeah, I think you can get it to do things like that,
Okay.
but when you start going down that road, the customer gets that impact. So they go and try and hit the site, and they're sitting there while it's checking out and recompiling everything, and we don't want that. So we want to make sure that we get the build on, it's working, and then it's back behind the load balancer so that it's invisible.
and that's kind of a best practice policy that's part of Intuit's guidelines for doing stuff is that.
Most of the time I've seen it has been you have two directories, and you swap, and so you get a point in time change. And then the other thing is, did you guys ever look into other what do they call Puppet or CF Engine, the other configuration management utilities for doing your actual deployment, or was it all because it was Jenkins driven?
Was Jenkins driven? We knew we wanted to use it.
Okay.
Some other teams at Intuit who are coding in Ruby on Rails have been using it very successfully. So that's why
If they're using like Capistran and
Other stuff that was secure shell deployment sort of stuff, rather than wrapping. Okay.
And we said that the automated deployment is something that automated deployment to production is actually fairly recent because it was tied in with the data center migration. But running Jenkins as a build server to do the validation of builds and then adding in the unit tests has been a journey over the last, I'd say, about 18 months. We started using it and then gradually increasing test coverage and adding new projects to the configuration. So at that point, it's very easy to do, and then of course we've just built on that to take this further and further.
Okay.
And like kind of some downstream benefits of doing all this work, or that we just did a huge data center migration, and because we invested all this time and all the automation that we had, we got over there and were able to immediately identify any failing cases that were because of the new data center. We were able to fix them very quickly and iterate really quickly on getting them back out. Where there were other people that when they made the migration, because they hadn't made that investment, they actually would have to completely roll back to the old data center, wait a few days and do it again, and they which meant that they were weeks in migration, and it was one day for us.
Well, not only that, but I would say
Not even a
the,
whole.
the bulk of the teams that have gone through this migration, it's been a lot of very, very late nights because they don't want to take the risk of doing this in peak hours.
We did it.
But we did it, what was it, 1, 2 o'clock in the afternoon?
Yeah.
And people were like, are you crazy? And we're like, well, if we have a problem, we want to make sure people are around to help us. So,
We wanted to make sure people were around to help us and that we had real customers facing the site so that we weren't trying to be the customer, because, you know, we're engineers, so we're going to be like, let me test all of my successful paths.
And the first day we switched to the data center, we did 3 deployments that first day.
Yeah.
We're just,
And that was it. So we were really lucky that, you know, that I don't know if it was foresight or not, but it was lucky that we had invested all of this time. And it really, I don't think, I mean, both of you were given this as a white space, not white space per se, but a challenge
yeah.
that you could do with some of your other time, and look how it paid off.
Very cool.
definitely.
Thanks, guys.
So where's the swag?
Yeah.
Swag?
Yeah, don't you have like shirts or anything?
Sorry.
Sorry.
Hats?
I have this one, but I'm using it.
Beer cozies or anything?